So the results here are sort of focused on visualization rather than code quality improvements, which was something we were looking at as a part of the project as well, and we presented during the midterms. This particular one is more about the final data loading and the outputs, visualization outputs. So let's get into it. So when I started this project, I really love the planet. I am an environmentalist. I have not hugged the planet, but I've hugged a fair few trees. So there is this amazing music video where it's produced in a 3D graphics mode, where the musician has his avatar going and hugging the planet, and it's created in a commercial rendering package. And I wanted to create something, you know, that will let you do this with real data, add yourself to it, and, you know, have some fun with the data, use it for storytelling as well as science communication. If you're a creative or a scientist, scientists have difficulty getting from the equations and the maths and the computing to telling the story about why the work is important. So ESoWC does amazing visualization work that sort of drew me to this stuff. I was working on this anyway. So yeah, it was a great start. So this is a nice song. I will not play it here, but sort of what we were going. So we're really living in the real world. People are talking about the metaverse and things in the technology community. We are not in a metaverse, or I don't know. But ECMWF is all about simulations going forward in time, doing the reanalysis, going back in time, and tying it all together into a coherent picture of what the Earth has been through and what it will be in the short term, so on. So the aim was to cover as much ground as possible in supporting the GRIB format and visualizing that, loading data from it. We got to where we got to. We pushed hard. ESoWC pushed hard. I provided direction where I could. She did a bunch of validation on stuff. Especially on the forecast side. So we'll go through some of the successes and learnings we have, and obviously a lot still to do. So we'll talk about that near the end. So one of the successes is after the code quality improvements and all of the sharpening the axe stuff, the loading is fine. We can chop up the GRIB, and that's fine. So the BlenderNC is easy to install now. I struggled a bit to do it fresh on Windows, but that will be documented and any gotchas captured. There's support for ERA 5 LAN. There is also support for forecast GRIB files. So that's good. So it basically is one step in our journey, getting it from the file to the RAM that Blender will use. And then it will get from the RAM, push it to the screen. So I have a short 2 minutes here on the data loading. So this is Blender for those. It's a notoriously complex interface to use. This is Blender 2.92. You basically click on a little folder icon, just look at the mess that's my file system, and then pick up a file. So I've got various files. Sylvie, our mentor, sent us some forecast data, thankfully, and ERA 5 I got from the data dissemination portal. And you can see that the variables that are loaded into it. When you go through, and then I will just do a couple of different ones. So I have tested this with ERA 5 LAN, and some forecast files. So in the interest of time, I'll share the slides after this. We'll just skip over this section of loading the different ones. I just included a full video here. So the next step, obviously, after you have pushed it from the disk to the memory of your visualizing engine, in this case Blender, the next step is to push it to the screen, to render it, to push it to even the files, to make a video. So that's sort of using the GPU renderer. So BlenderNC has this node system, modifiers. There's a lot you can do. We're still writing the advanced usage tutorial in the documentation. ESoWC probably is a better person to write it than myself. I use it at a very basic level. I provide best coding best practices guidance and some of my knowledge of the file formats and such, and data scaling and all of those. So there has been a bit of documentation. Advanced usage has been partially documented, and then the ultimate things that has been discussed a few times in the previous presentations is scaling. So doing headless run, which is without a screen, public cloud rendering, all of the world at very high resolution, long time series, that sort of stuff is like visualization is involved there. So the visualization samples I will quickly go through are just the simplest possible example. Just one instance, one frame, one thing. A series, couple of time series of the past based on Era 5 land with a little bit of a story, and a bit of the future series in the Atlantic hurricane season of a particular hurricane, Peter, which was active recently. I chose the hurricane because it's named after a rock. A bunch of wind named after a rock sounded fun, so I chose that. So the instance frame is really easy. You should be able to get to do this in 5 minutes. You download your data, you are prepped, your BlenderNC is installed, you launch it, you load the data, and you essentially do something very simple. You press F12 once your data is loaded, and you get like a simple sphere, so that your data is loaded, you get something basic, simple, and a color bar saying this is the temperature in kelvins. Something very basic and simple if you have one instance. If you have a time series, you download the data, data is bigger, download time for, I think data prep time for me took like an hour, the download time took a fair bit, I left it running overnight. It was something about the past. I like names, I chose a hurricane, Dorian, the story of Dorian Gray, someone who always stays young, and the rendering of him, the painting ages. So I chose a fun name here as well. So chose Hurricane Dorian as the history, but Dorian Gray's story is not a fun story. It's yeah. Anyway, the Dorian story is like science communication story as well. The science was very politically incorrectly communicated during Dorian, and some of the probabilistic stuff that BlenderNC is currently missing in showing the envelope of the path needs to be implemented as well. One of the other things that needs to be implemented in BlenderNC, and is one of our pillars of work to do, is support for 4-dimensional fields. So this is what happened when I tried to render the data for Dorian I had downloaded very painstakingly. So yeah, we are not there yet, but it's a learning exercise and continuous journey in getting things done. So the next one I wanted to do was go through a time series of the future using the ECMWF simulation outputs, forecast outputs. And this one is interesting because this is the current hurricane season, and the toll for the Atlantic hurricane season this year has been quite big. $55 billion US, and then around 150 lives. And the name of the hurricane is Peter, which comes from the Latin word Petrus, and it's basically the Earth acts as a big gravitationally coupled gears spinning the hurricane using the Coriolis forces, and that's quite interesting to see. Sylvie sent me the data just in time for me to prep this. I got this up. I'll play a little video of what happens when you use BlenderNC to quickly render one of the fields. It's a very slow video, and you can see the rendering on the globe. I haven't done any dramatic camera animations or anything, which ESoWC is very good at doing. And if you have a storyboard, you can build a lot on this, but already you can see some good shading and coloring and the potential of this, what this can become if you have a good story to tell. Yes, again, this is a very short video, so I'll just move on from this one. So the rest of the time, I spent time with several calls with Stefan and Sylvie discussing the ECMWF weather cloud, how to take advantage of that for our project, how to enable a lot of others to use Blender on the ECMWF weather cloud to do this sort of interesting renders and tell the story, get better science communication, and sort of merge the outputs on the website with the inputs coming from the science side. So yeah, so like use the SSH and X Windows access. So create a render farm. So briefly, for a brief period in New Zealand, while all the big movies were being made, Lord of the Rings was being made, the biggest computer was not a weather simulation computer. It was the Weta Digital, was the movie making computer in New Zealand. So movie making is a valid use of HPC systems. And Stefan has tried some of these, and there is currently sort of a gap in the X Windows support in the European Weather Cloud, which we are going to Stefan is going to look to address. So I tried something similar using the public cloud. Recently, Amazon Web Services has released a product called Nice GCV, which lets you run Blender remotely and get the display pumped out. So I had some learnings there. I was on a call with the Nice GCV HPC experts today in Singapore and in Australia, going through their solution, kicking its tires. We got to a stage where we agreed that this will be feasible, will be a great application of the public cloud to spin up Blender instances, create a render farm, render weather data for specific storytelling purposes for Australia, for ECMWF, anyone who has weather data. AWS is all about it. I got in touch with the AWS division, which does this through my work in HPC and WRF, running HPC clusters in AWS for that purpose. So the stage we got to was essentially, there are lots of fine-tuning things done. I had to actually first get access to a GPU machine. That took a few hours. Once, if you're ready and you have all of this parallel cluster stuff set up, nice GCV set up, it works really nicely. The learning is that you have to have all of those and an infrastructure team to do it. I can do all of these things for myself because of my personal experience. So you can get like a pretty big node with extra large node with a GPU from which you can send the display to yourself and see the results. The possibilities are essentially, there are ideas. There's a book I like by Ramiz Nam called The Infinite Resource. The possibilities are endless as we continue to engage with ECMWF, get new ideas, put things together. Some of the ideas we have put down here, like wind vectors as hairs. Blender supports these hairs for characters. You can make the Earth wind vectors around those. More stuff around X-array, non-uniform grids. If the data gets too big, stream the data from the cloud or via the API. Any number of things is possible now that we have a good framework, good development flow, good mentorship, and access to the data. So the team, as Julia was saying, is pretty distributed, but weather affects us all. Gishini is in Kenya. I am in Adelaide. I'm not in Sydney. I'm in Adelaide, Australia. And Joshua has just gone back to Mexico before he starts his postdoc in France. So yeah, but the weather is a common theme that affects all of the planet. And yeah, I have a big blurb of the conclusion, but I just would say that, this has been a great experience. And I'm looking forward to the BlenderNC becoming as popular in the weather simulation visualization community as Blender has become in the mainstream 3D graphics community. Thank you for the opportunity.
Thank you, Tisham, for your great presentation and also sharing with us your great developments you provided to the BlenderNC community through the Summer ESoC project this year. So thanks a lot. You also already shared with us that you have endless possibilities to collaborate and also to enhance even your developments and to make Blender a stronger tool, I would say, in the weather and climate community. And we are quite excited to see what is yet to come. So thank you for joining us today and for also being part. So to you, Josre and Gicini, for being part of ECMWF Summer of Weather Code. It is a great pleasure to have your project and have you working on BlenderNC. And thanks for your time today.